There are 5 more examples for me to continue on for solving for the best method for quadratics. And so here are the last 5 examples out of 10. So as I'm looking at the problem when I start, I want to go kind of along with my flow chart. So I notice that standard form is ready. I want to look, can I factor easily? If not, then look for is the middle term missing, and then you can do the square root method. But if both of those are a no and you have A is 1 and B is even, then what we would do is complete the square. And if none of those are true, I'm going to use quadratic formula. So that's just kind of my method for how I pick my best way to solve a quadratic. So as I'm looking at this problem to start, looking at it, I just don't think that factoring is going to be very easy. It looks difficult when my front term is not 1. And so then I'm going to say, no, it's not easily factorable. It's not missing the B term. And A is not 1. So I'm going to go with quadratic formula on this one because all those other things that I had been talking about were a no. And so I'm going to start with this one with quadratic formula. So again, not easy to factor. And my bx, the linear term, is not missing. So I cannot do the square root method. And then my a is not 1. And so here we go. Here is the quadratic formula. And I'm going to start with just kind of identifying the 3 parts. A is a 6, B is a 13, and C is negative 17. So let's start. X is equal to opposite of B plus and minus the square root of our discriminant, B squared minus 4AC, all over 2A. And so I'm going to start kind of putting those pieces in here. But I like to start with my discriminant first. And so I'm going to start with this piece, B squared minus 4AC. This is going to be 13 squared minus 4 times 6 times negative 17. And 13 squared is 169, and 4 times 6 times negative 17 is negative 408. And if I add those together, because minus a negative, I get 577. Yeah, I'm definitely glad that we're going to use the quadratic formula. So I'm going to write down opposite of my b, so opposite of positive 13 is negative 13, plus and minus the discriminant under a radical, 577, all over 2 times 6. And now what I'm going to do next is get the decimal for the square root of 577. So 577 as a decimal is 24.02. I'm going to round that to. And then we're going to divide by 12. So I'm going to do one answer where I'm going to use that addition sign, and the other answer where I'm going to do the subtract sign. So negative 13 plus 24.02, and then we're going to divide by 12. So let's clear that out. Negative 13 plus 24.02, and that's 11.02. And if we divide by 12, I get 0.918, so I'm going to round that to 0.92. And then I have one more answer here when we subtract. So negative 13 minus 24.02. So that's negative 37.02. And then divide by 12. And I get negative 3.085. Or I'm just going to round that to 3.09. Just a couple decimal places should be good enough. So I'm glad we went with quadratic too, because we're going to get decimal answers, which there's no really other way you could have solved this. All right, here is another example. Example number 7. I notice that I have no linear term, and so I'm going to pick the square root method. And that's because my linear term is missing. So I'm going to subtract 16 on both sides. Here I'll have 4x squared is equal to 0. Well, this is going to be quick and easy, I can already tell. If we divide by 4, I'm just going to get 0. And what times itself will make 0? Well, I mean, you can square root, but hopefully you'll know this one. You just get the number 0 here. So nice quick one there after the quadratic formula. It took us a while. Okay, for the bottom one here. I noticed that I have 1x squared plus 1 minus 20. I'm going to check for factoring and see if that will come out nicely. What two numbers multiply to make negative 20 and add to make 1? I'm thinking a 5 and a 4. It just depends which one is negative. If I have negative 5 times positive 4, when I add, I'm going to get negative 1. But 5 times negative 4 is going to get me positive 1. And so my factor pairs are going to be an x with a positive 5 and x with a negative 4. And so I'm going to pick factoring because it was easy. And so now set your factors equal to 0. If x plus 5 is set equal to 0 and we solve for x, one solution will be negative 5. And then x minus 4 equal to 0, if we solve for x, we're going to get a solution of positive 4. So 2 quick and easy answers for that. All right, 2 more left. My front term here is negative 16, and then I have negative 50 and positive 21. I have a feeling that factoring would be awfully difficult for this, and I'm not missing my linear term, and I don't have a front term of 1. So again, I'm going to use quadratic formula for this one. So here's my reasoning why. It does not look easy to factor. So there's one reason. The middle term, the bx, is not missing. So I'm not going to do square root method. And then last, because my a is not 1, I'm not going to end up doing the completing the square method. So I'm going to go with quadratic formula, and I'm going to write that formula out for us here. Opposite of b plus minus the square root of our discriminant, b squared minus 4ac, all of that divided by 2a. And I'm going to start with my discriminant piece. So I'm going to label my a, b, and c just so I get my parts correct here. So b squared minus 4ac is going to be negative 50 squared minus 4 times negative 16 times 21. We're going to get a pretty big number here, which is okay. Negative 50 times negative 50 is 2,500. Minus a negative means we are going to end up adding those. So 4 times 16 times 21 is 1,344. And now I'm going to add those together, and I get 3,844. Whew, that's a big number. All right, so here will be my quadratic formula. Opposite of my middle term, so opposite of negative 50 is positive 50. Plus and minus the square root of that number we just found, 3,844, 3844. And then divide by 2 times your a. A is negative 16. All right, now I'm going to see what the decimal is for this. Square root of 3,844. Oh my goodness, you're never going to believe it. It's a whole number, which means we could have factored. Well, I'm glad we didn't factor, because that looks pretty tough to me. So here we go. I'm kind of excited now. This isn't going to be super difficult from here. 50 plus or minus, this is a whole number here. Square root of 3,844 is 62. And then we're going to divide by double negative 16 or negative 32. So again, we're going to have 2 answers, one when we add and one when we subtract. All right, so 50 plus 62, and then divide by negative 32. And 50 minus 62, and then divide by negative 32. This is going to get us 50 plus 62 is 112. Divide by negative 32. So divide by negative 32 is a fraction, negative 7/2. Or if you want to write negative 3.5, those are the same answer. And 50 minus 62 is negative 12. Divide by negative 32. Negative 12 divided by negative 32 is 3/8. 3/8. Or if you want to write the decimal down, that would be 0.375. So maybe, you know, quadratic formula was the best because we did get some decimal answers, negative 3.5 and 3/8, or, you know, almost 0.4, but it definitely would have been a challenge to factor regardless. All right, here is our last one. When I'm looking at my my problem, the first thing I want to do is I want to factor because it's really the quickest and easiest. But two numbers that multiply to make 15 and add to make 9, I'm pretty sure is not going to work because 5 and 3 is going to make 8. It's just not going to be 9. And so since factoring isn't going to work, I'm not missing my linear term. I'm going to have to try quadratic here. Okay, so again, A here is 1, B is 9, C is 15. I'm going to start with our B squared minus 4AC, or 9 squared minus 4 times 1 times 15. All right, this is going to be 9 times 9, or 81. And 4 times 15 is 60. So I'm going to get 21 as my radical. So x equals opposite of b, so negative 9, because opposite of positive is negative, plus and minus the square root of 21, all over 2a, or 2 times 1, is going to be negative 9 plus and minus the square root of 21 over 2. So one answer when we add, one answer when we subtract, and I'm going to put the decimal down here. Square root of 21 is 4.58. I'm going to round, 4.58. So negative 9 plus 4.58, and then we'll divide it in half. And negative 9 minus 4.58, and then we'll divide that in half. So negative 9 plus 4.58, divide by 2. I want the decimal here. Negative 2.21 is one of my answers. And then negative 9 minus 4.58, and divide by 2 is going to be negative 6.79. So 2 decimal answers, and I'm glad that we went with quadratic. Again, not factorable. Our middle term was not missing. And our, I'm not going to do completing the square because our b was not even for completing the square. And so quadratic ended up being the best.